some general considerations about the development of alternatives, other things can enhance capacity management. First, the design flexibility into system. The long-term nature of capacity decisions and the risks inherent in long-term forecasts suggest potential benefits from designing flexible systems. For example, provision for future expansion in the original design of a structure can be obtained at a small price compared to the cost of remodeling it. Thus, if future expansion of Toyota manufacturing plant seems likely, water lines and water disposal lines can be put in place initially so that if expansion becomes a reality, modification to the existing structure can be minimized. Second, take stage of life cycle into account. Capacity requirements are often closely linked to the stage of the life cycle that a product or service is in at the introduction phase. For example, it can be difficult for a car business to determine the size of the market they are in and the firm's eventual share of that market. In the growth phase, the overall market may experience rapid growth. However, the real issue is the rate at which the organization's market share grows depending on the success of the organization's strategies. They regard this as a good thing because they see this will increase volume and thus increasing profits. However, increasing output levels require increasing capacity, and that means increasing investment. Furthermore, one should take into account the possible moves of the competitors, which would increase the risk of overcapacity in the market. In the maturity phase, the size of the market levels off and organizations tends to have stable market shares. And in the decline phase, an organization is faced with underutilization of capacity due to declining demand. Third, take a big picture approach to capacity changes. When developing capacity alternatives, it is important to consider how parts of the system interrelate. For example, when making a decision to increase the number of rooms in a hotel, one should also take into account probable increased demands in parking, food, and housekeeping. The risk is not taking a big picture approach is that the system will be unbalanced where bottleneck operation exists. A bottleneck operation is an operation in a sequence of operations whose capacity is lower than that of the other operations. For example, if you produce bottled water, the bottling, labeling, and boxing of the product could all be done at 100 bottles per minute. But if your capping machine can only do 10 bottles per minute, the rental production operation will only produce 10 bottles per minute. Fourth, prepare to deal with capacity chunks. Capacity increases are often acquired in fairly large chunks rather than smooth increments, making it difficult to achieve a match between a desired capacity and feasible capacity. For example, the desired capacity of Toyota of the certain operation is 55 units per hour, but the machines used in the operation are able to produce 40 units per hour. One machine by itself is short of 15 units per hour, but two machines will have excess of 25 units per hour. Fifth, attempt to smooth out capacity requirements. Unevenness in capacity requirements also can create certain problems. It is affected by seasonal variations. One approach is to identify products that will offset each other, such as demand for water skis, which is greater in the spring and summer months, and demand for snow skis, greater in the fall and winter months. Products or services with complementary demand pattern involves the use of the same resources but at different times, so that overall capacity requirements remain fairly stable. 6. Identify the optimal operating level. Production units have an ideal or optimal level of operation in terms of unit cost of output. At the ideal level, cost per unit is the lowest for that production unit. Economies of scale are the reduction in average costs arising from an increase of an operating unit. For example, Toyota rents some Tundra manufacturing equipment for $12 million per year. The equipment has an annual capacity output of 150 Tundras. If Toyota expects to produce 125 Tundras a year, rental expense per truck is 96 pesos. However, in these economies of scale, increase in average cost of production as the scale of operation increases beyond a certain level. Thus, if Toyota produces 120 Tundras a year, rental expense per unit will become 100 pesos. And last, number 7, choose a strategy if expansion is involved. Now, let us discuss what constraint management is. Simply put, a constraint is anything that limits the performance of a process or system on achieving its goal. It can be physical, or they could be policies. Within these two broad categories, there are 7 basic types. 1. Market. Not enough demand for a product or service. For example, Toyota wanted to produce 120 Tundras per year, but because demand is insufficient, they decided to make their output lower than the desired output. Number 2. Resource. Not enough people, equipment, or facilities to satisfy the demand for products. For example, canned goods is in demand whenever there is a typhoon, but it's not enough to supply many customers because there is insufficient resources to meet this demand. Third, material. Inability to obtain required materials in the quantity or quality needed to satisfy the demand for product or services. Fourth, financial. If there is insufficient fund to do the operation. For example, Toyota wants to have a solar-powered car, but their budget is not enough to make it possible. Fifth, supplier. Unreliability of a supplier or vendor or excessive lead time in responding to orders. For example, the car business import cars from other countries to meet their capacity. However, because of the unreliability of the supplier and their delay in delivery, the firm cannot meet their capacity. 6. Knowledge or competency. Knowledge to improve business performance is not resident within the system or organization, and if people don't have the skills necessary to perform at higher levels required to remain competitive. For example, IKEA wants to manufacture a television set, but their knowledge and the skill of their people is limited in manufacturing only cellular phones. And last, 7. Policy. Any law, regulation, rule, or business practice that inhibits progress towards the system's goal. For example, DTI has a price policy in some goods in the market, but one product price should not exceed to what has DTI implemented price. This will limit the output of a firm, especially if their cost in the product is high. Constraint issues can be resolved by using the following steps. First step. The first step is to identify the system's constraint. What limits the performance now? Once the system constraint is identified, if it can be broken without much investment, do so, and revert to the first step again. If it can't be easily broken, proceed to the second step. Second step, change the operation to achieve the maximum benefit, given the constraint. For example, if the constraint is in market demand, it means that catering to the market has to win more sales. Third step, subordinate. Make sure that other portions of the process are supportive of the others. Fourth step, explore and evaluate ways to overcome the constraint. This will depend on the type of the constraint. For example, if demand is low, advertising or price change may be an option. And the last step, the fifth step, repeat the process until the level or constraint is acceptable. That capped my part in our report. I am Marino Biscocho.
And I am Yulomar Ahusan. And we've just delivered our topic on strategic capacity planning and products and services.
We hope that in one way or another, we are able to impart some important information on the subject matter.
Thank you for lending your ears. Good day, everyone.